Hello friends, welcome to this Hadoop tutorial. Myself Vikas, and through this series of tutorial we are going to learn about Hadoop and its various related technologies like MapReduce, Hive, Pig, HBase and so on. But before going into the details of all these, first we should know about big data, because here the problem is big data and the solution is Hadoop. So today we are surrounded by lots and lots of data. So let's quickly go through some of the sources of data. The social networking site data. Nowadays almost all of us are having the account in social networking sites like Facebook, Twitter, LinkedIn. There we used to upload the images, videos, we used to chat, we used to connect with friends. Social networking sites like Twitter, which used to generate millions and millions of tweets per second. So these social networking sites used to generate large amount of data. Emails. Again, almost all of us are having the email account, and that too more than one. There we used to write the email, we used to attach the document in the email, and we used to send it to other email account holders. So these emails are also generating large amount of data. The documents. Nowadays all the offices are minimizing their paperwork and they are generating their documents in the form of PDF, Word file, Excel. So again the document is also contributing to the large amount of data. So is the case with audio recordings, the CCTV footage where the video is getting recorded on 24/7 basis. The enterprise data, so all those RDBMS data are the enterprise data. And the machine log data like the application server log, the server log, the CDRs, that is call detail record, the click streams where the user activities are getting recorded by the websites. So again the machine data log is also generating large amount of data. Same is the case with the stock exchange, the sensor data, the satellite data. So basically what all these sources of data are doing, they are generating a large amount of data, and the size of the data is so large that it is becoming difficult for the traditional databases to store those data, and it is becoming difficult for the traditional technologies to process the data. So this is what we call the big data. So big data is something, so it's a term used to describe a massive volume of data, and the size of data is so large that it is difficult for the traditional technologies to store the data and to process the data. So we should concentrate on the 2 points, that the size of the data is so large that it is becoming difficult for the traditional technologies to store the data and to process the data. So this is the definition of the big data. Okay, so when we are talking about the big data, then the size of the data is in the terabytes or in the exabytes. So let's quickly go through the size of the data. So I think we should almost all of us are knowing that 1024 MB equals to 1 GB, and 1024 GB equals to 1 terabyte, and 1024 terabyte equals to 1 petabyte, and 1024 petabyte equals to 1 exabyte, and 1024 exabyte equals to 1 zettabyte. So these are some various units of data. So when we are talking about the big data, then size of the big data are measured in the petabytes or in the exabytes or in the zettabytes, even in the zettabytes. So here if we convert 1 exabyte of data into the gigabyte, then it will be something around 1024 into 1024 into 1024 GB of data, and it is approximately about the 1 billion GB of data. So when we are talking the size in exabyte, then it means a lot of data, because 1 exabyte of data is approximately about 1 billion GB of data. So let's quickly go through the wiki and search the big data over there. Then we could see some of the examples of the big data, right? Like there is a large hardened corridor experiments where the data, if you can see here, the 500 exabyte of data is generating per day. So just imagine, it's a large amount of data. So here the 500 exabyte of data is generating per day, and the size of data is so large that it is becoming difficult for the traditional technologies to process the data, and that's why they could process only up to 0.001% of data. So these are the problem with the big data. Mainly the problem are in the storing the big data and processing the big data. So if we'll talk about the present world data, then almost 90% of the present world data has been generated within the last 3 to 4 years. If we look closely into this graph, then picture will be more clear. In 1990s, we were having only the enterprises data like the RDBMS data and all. But with the advancement in the technologies, the data started growing in the form of documents like Word, Excels, PPTs, PDFs and all. So where in 1990s the maximum size of the data were measured in terabytes, in 2000 the size of the data started getting measured in petabytes. And with more advancement in the technologies in 2010s, the more and more data started growing in the form of the social networking sites, the video sites like YouTube, the messengers like WhatsApp, Wikipedia, Twitter. If you will take simple example of mobile phones, nowadays almost all of us are having the mobile phone, and we used to take the images, we used to take the videos and save it in the mobile phone. And also we used to share all those data in the social networking sites, or we used to share the videos in the YouTube. So due to all these factors, the data size is growing more and more, and if this trends will continue, then the size of the data will started coming in zettabytes. And due to this data growth, the traditional technologies also started facing problems, mainly in storing all those data and processing all those data. So the big data is defined into three types. Those are the structured data, unstructured data, and the semi-structured data. So the structured data, all those data which are stored in the relational database are termed as the structured data. Why? Because before saving the data, we are predefining the data model. Like before saving those data, we are defining the table, we are defining the column name, we are defining its type, we are defining its size. So if you see the example of Oracle database, then here, before saving the customer data, we have first created the table customer, and we have created the columns over here. We have defined the data type of the column, and we have predefined the size of the column. So before saving the data, we are predefining the everything, and after that only we are saving. So if you'll see here, in the first name column we'll just save the first name. Similarly, in the last name column we'll save the last name. So is the case with the address, city, and age. So by defining all these, we are making the relational database data as the structured data. So what are unstructured data? It is just the opposite of the structured data. Here we are not predefining anything, we are not organizing anything, or we don't have any predefined manner. So the example of the unstructured data are all those text heavy data like a PDF, the Word file, the email bodies, the blog which we used to write. Also all the images, the video files, all those are the unstructured data. Why? Because whenever we are writing something in the Word, we are not predefining anything. We don't have any predefined columns, or we don't have any predefined data types. We are free to write anything. So those data are the unstructured data. So the examples are all those text heavy data like PDF, Word file, the email body, the blogs, the videos, the video files, the images. So all those are the unstructured data. So what is semi-structured data? So as the name suggests, it is the cross between the two. That is, in the semi-structured data, both the data are present, the structured and the unstructured one. But the percentage of the unstructured data is more as compared to the structured one. Here the work of the structured data is only to provide some sort of metadata. For example, if we see whole email, then here the email, as I have previously said, the email bodies are the unstructured data. But if you see here, the information of the sender, information of the receiver, or the subject line, so all these are providing some sort of information about the unstructured data and making the whole email as the semi-structured one. Also, if the XMLs are also can be termed as the semi-structured data. Why? Because here, if you will see, the data between both these tags, both these name tags, are the unstructured one, but the tags data are providing some sort of information. Like here, the tag name is providing information like Carrie Fisher is the name. Also, if you see that the tag street, if you will see the data between the tag string, then we can easily understand that this data is telling some street name. So is the case with the city or the address. So here also, all those that tags data are providing some sort of information, and the data between both these tags are the unstructured one. So XML data is also termed as the semi-structured data. We can also take the example of images nowadays in social networking sites like Facebook. Whenever we are uploading the image, then there we are getting an option of providing some tags. So those tags are providing some sort of information about those images and making the whole as the semi-structured one. So is the case with the video. So whenever we are uploading some video in video sites like YouTube, there also we have been given some options like providing some tags for that video, and those tags are providing some sort of information about those video and making data as the semi-structured one. Again, we can take the example of the Word file. If you'll take the example of Word file, then in the header part we are having some sort of subject line, we are having the author name, we are having the date. So all these sorts of data are providing some sort of information, but the whole body of Word file are again unstructured one. So providing some sort of information by writing the author name or the date or the subject, we are making those data as the semi-structured one. So big data is a combination of both structured and unstructured data. Here we are not mentioning about the semi-structured data, because semi-structured is a combination of structured and unstructured data only, and 80% of the big data is the unstructured one, and only 20% of the data is the structured one. And if we'll talk about the complexity, then unstructured data are more complex than the structured one. So if you'll see here the data growth chart, here the y-axis is representing the unit of data in exabytes, and the x-axis is representing the year. So if you see in year something around 2006, 7 or 8, we are having very few amount of data, something around 500 to 1000 exabyte of data. But as the time progresses, here if you see in the 2011, 12, 13 or 14, and here in the 15, the data size has increased something around 6000 or 7000 exabytes of data. So it's a very large amount of data, and if this rate continues, it is predicted that in 2020 the size of the data will increase up to 36 to 37,000 exabytes of data, which is very large in size. And here the yellowish part is the unstructured data, and the bluish part is the structured one. And if you see here, the 80% of the data growth is the unstructured data, and only 20% of the data growth is the structured one. So the unstructured data are more complex than the structured one, and it is becoming more difficult for the traditional databases to store the unstructured data, and it is becoming more difficult for the traditional technologies to process the unstructured data. So IBM has given the 4 characteristics to the big data, which is termed as the 4 V's. The 4 V's are volume, velocity, variety, and veracity. So volume. So as we have already seen, and that there are various sources of data, and these sources are creating the large volume of data. Velocity is something speed of generation of data. We have already talked about the social networking sites like Twitter. So Twitter used to generate millions and millions of tweets per second. So velocity is the speed of generation. Also velocity is the rate of analysis of the data, is also termed as the velocity. Variety, we have already talked about the unstructured, semi-structured and the structured data. So these are the varieties of data. And the veracity. So data inconsistency due to the incompleteness of data are termed as the veracity. So these are the four characteristics given by IBM, which is termed as 4 V's. Those are the volume, variety, velocity and veracity. So let's see the benefit of big data. So big data may be as important to business and society as the internet has become. Why? Because more the data, more accurate will be analysis. It's obvious, if the size of the data will be more, then the result of the analysis will be more accurate. So big data is useful in various sectors like healthcare sector, weather forecasting, retail sector, government sector, insurance sector and all. And if the for weather sector, if the weather forecasting team is doing the analysis in large size of data, then it would be helpful for them to produce some more accurate weather forecast. Same is the case with the healthcare sector. If the medical expert team is getting the medical history of 30 to 40 years, then it would be easier for them to produce some better result for the diseases. And same is the case with the government sectors. For government sector, big data is helpful in fraud detection, the cyber security, general election, in development initiative. If you see the wiki, then you can see big data analysis was in parts responsible for the BJP and its allies to win highly successful general elections. And also, big data analysis played a large role in Barack Obama's successful 2012 re-election campaign. So, big data is helpful in retail sectors. For a company, the big data is helping to do the sentimental analysis. So, by doing the analysis of the reports, companies can know in which products particular customers are interested and in which products the particular customers are not interested, and by that they can target their customer and they can increase their profit. If you want to see application of big data, you can always refer the Wikipedia, and you can see the big data is helpful in various sectors like government sectors, in the manufacturing sector, the cyber physical models, in media, in technology, in retail sector, in retail banking, the real estates and science. So you can always go through this. So let's have some quick review of what we have learned till now. So we have seen the various sources of data. We have seen what is big data. So big data is a term used to describe the massive volume of data, and the size of data is so large that it is becoming difficult for the traditional technologies to store the data and to process the data. We have seen the types of big data, that is structured data, unstructured data, and the semi-structured data. Also, we have seen the data growth chart, and we have learned that how the 90% of the present world data has been generated within the last 3 to 4 years. Also, we have seen the IBM's definition of big data, that is also known as 4 V's, that is volume, velocity, variety, and veracity. Also, we have seen the application of the big data. So in the next video, we are going to see about the limitation of the traditional technologies in handling the big data with real life examples. Also, we will see how Hadoop solves this problem, and again we will see what happens when we save the data in Hadoop. We will see something about the data replication, rack awareness, and all. So till now, I hope that the concept of the big data and its related problem would have been clear now. Thanks for watching the video.